All right, I think let's get going. So again, welcome to everyone. Thanks for joining us. It's really strange joining you from the office with my, mask, my sanitizer. So we're Corona ready. We've got inverters ready if there's any power cuts through ESCOM. So we are ready. Nothing's going to stop us today. We decided months ago to have this event with you guys. We created a little studio downstairs in our training room, and we brought in a customer or three over the week, and we are very excited to host some form of event with you guys in this week. So thank you for taking these 2 hours every day for the next 3 days. Hopefully you're going to join us for the week, and we'd really love to spend the next few days with you going over the future, this new era that we are in. And I think it's really exciting and challenging. This is the first time we've ever had an event like this. It's groundbreaking for us, and we want to really take this trend. And I think we're all evolving as companies in this COVID lockdown period. We've all had a chance to rethink how we do things, and this has been really exciting for us. So a little bit of an introduction or the agenda, how this is going to work. So I'm going to spend the next half an hour talking to you about all things SolidWorks and what's new. For the next half an hour, it's going to be broken up into 3 sections. So I'm going to be talking, and then we're going to go down to the studio where Idis is hosting one of our customers, and we're going to have a talk with Raphael Smith from BMEC. Then Idis is going to throw the ball back to me, and I'm going to end off the day with assemblies and drawings. What's new? So just some points, guys, before we get going. The event is divided into 3 days. After consulting you as customers, do you want a day event? Do you want to go out somewhere? What do you want to do? And most of the answers we got was, hey, keep it quick, keep it in the day, give it for 2 hours, and we will join. And that's why we decided to do the event like this. It's really exciting. If you are enjoying today and you want to get more of your colleagues on board or friends that want to join the event, let them go to our website, MECAD.co.za, and register. We're still allowing late registrations for tomorrow's session and Thursday's session. So the 3 days are going to be broken up into today, which is going to be doing normal CAD SolidWorks. Tomorrow we're going to do the multi-products, PDM, simulation, all those goodies, visualize, and more. And we're going to be having a guest speaker tomorrow, a really, really, really interesting guest speaker who you would have known, read on our website. We're going to have Robert Miller from the Eye Above talking about the development of their drone to hunt poachers. Really super interesting story. So don't miss that. And then on Thursday, we are going to introduce you to the 3D Experience platform in South Africa. Very, very excited for that. And again, we got our guest speaker, Ernie from MECAD, so that's going to join us again on Thursday to talk about how they view SolidWorks. So the third point we've got over there is the prizes. So I did a quick little video about the prizes. Just a quick little slide here. So again, as I said in the video, go on to LinkedIn. This is we're trying to make this fun still. It's very difficult not being together in the room with you. We normally laugh and have fun together, but we're going to try and do that in a digital form today. So we thought, go to LinkedIn, take a photo of you, if it's by yourself or with your team, just at MECAD Systems, so we get the message, and hashtag MECAD Systems so that you can search for it. It makes it a bit easier, and then post it. Say, hey, enjoying it, whatever your thoughts are, and we'd love to see those photos. And then what we will do is we will reply to you with your Uber Eats voucher to say thank you for joining us. So go ahead, and we want to see what you are up to and how you are watching as a company. We've had many phone calls with customers where guys are putting up projectors in the drawing office and joining like that as a team, having some pictures. So yeah, really great to see how creative you guys are for this event. So just again, the interface of Big Marker. As I start the presentation now, I'm going to show you a little bit about the interface. We have Q&A sessions. If you got questions, please put it in the Q&A section. If you got anything to say, use the live chat, and my team and myself will be there to answer your questions or just comment about anything that you see. I would really love to make this as participation friendly as possible. That's why we're using this Big Marker technology in order to give you handouts and interact with you as best as possible. And like I said before, we got Raphael Smith from BMEC, which is going to be joining us a bit later. So again, at the end of the event, give us your feedback on day one. We'll alter it as we go in the week if there's anything that we'd like to change. So just please give us the feedback as necessary. All right, so let's move on to the What's New 2021. Now you'll notice something slightly different. There's this 3D Experience Works name, and if you've been listening in the media or looking at SolidWorks online over the last few months or even the last few years, actually, this 3D experience is becoming more and more of a living blood of SolidWorks, and what is it? And we really want to unfold it and unwrap this over the next 3 days with you, and just to show you this new era of MECAD and with SolidWorks. And we are super, super excited to talk about this. So over the next 2 days, we're going to be dividing it up into SolidWorks CAD, as we all know and love, and we're going to be looking at the square robot assembly, which is a custom out of Boston, Massachusetts. It's an automated robot that goes and inspects petroleum tanks. Really, really cool. So we're going to be using their files over the next few days, and we're going to be introducing you to different aspects of this 3D experience platform, which will be in more depth on Thursday. And we're going to really go into depth and look at the 3D experience platform and how SolidWorks it really enables these to work together. So we're going to be looking at, today is going to be the expanded functionality in SolidWorks. As you know and love your SolidWorks, what kind of extra functionality do you have in the new software? What are we adding? What is coming? What is happening? And what is available right now? Performance, performance, performance. I've been on stage talking about performance for so long, and I can tell you what, this 2021 release is incredible. As soon as you open it and start working with your assemblies, you feel a change immediately. It's really something to experience. And I'm going to be digging into what's changed in SolidWorks with regards to performance, and we're going to be looking at this live in action. And then on Thursday, Yvonne, one of our engineers, is going to be looking at, and I'll be introducing this to you as well on Thursday with Yvonne, looking at cloud collaboration. You know, this lockdown has completely changed how we hire, how we work, you know, the kinds of locations we can work from. You know, we've had people working, we're in Cape Town, and we've had customers that have been, you know, moving out to all these small towns like Hermanus and you know, in Somerset West, and their offices in Cape Town. Is just a mission to travel around, and how we're able to use technology like collaboration tools to work with your SolidWorks and connect with your data in the cloud. And we're going to show you not only how to store your files, but how to work together in teams. It's really amazing to look at this technology and look how it works. And then we talk about super cool, uber, next level design validation. And I'm going to talk about it in the next few slides, how SolidWorks has really expanded their technology by integrating with other platforms. And I'm going to talk about that in a second. But wow, the capabilities on really next level. And then finally, we're going to be talking about cloud design, not taking away your SolidWorks, but adding to it. You know, nerves modeling, you know, shape. You know, we got tools like that, and we got tools like XDesign or SolidWorks 3D Designer, which allows you to design in the cloud on any device and collaborate with your SolidWorks CAD. Unbelievable stuff, and we're going to go through that on Thursday. So this 3D Experience Works brand, what is that? Well, that is a combination of everything. That is the Gatias, the Simulias, the Delmias, the NetVibes, and Novia we've heard about. And this Dassault Systems group has really brought all of these tech developers together under one roof. And we're sharing technologies with these big brands like Simulia, which is incredible. So we got a Simulia Works brand, which is now going to be available to us to use with the power of the Simulia and Abacus solvers available to you as SolidWorks users, for example. And PLM services in Innovia. Really, really powerful stuff that we are sharing as a group now. And that's why you'll see this 3D Experience Works as a group of brands. So moving on to SolidWorks. What has SolidWorks been up to in the last year? And every year I stand on stage and talk about, you know, different features and different add-ins and different things we've modified and added. And every year someone said, you know, shouts out, you know, make it faster, you know, fix the bugs. You know, it's really interesting to get this kind of feedback every year. And SolidWorks really does listen. And I always say this, SolidWorks really does listen to their users, and they spent a massive amount of time over the last 3 years communicating with the user base, including ourselves. And we provide excellent feedback on the ground back to SolidWorks. And 58% of all development done in the last year has gone to improving the quality and the performance of the SolidWorks that we have and know and love. And then a further chunk of the pie is enhancements, and then the integration into the cloud with the 3D Experience platform, and then other applications. But you can see SolidWorks has spent a huge amount of time working on making your SolidWorks work better with workflows, bug fixes, and be a lot faster. So this is looking at the quality and the reliability of SolidWorks over the last 5 years. And the next slide I'm going to show you is going to talk about the severity of these SBR, these service pack reports, these bug fixes or workflow fixes, things that maybe not working right, or software functionality that's not working correctly, or something that just is not always reliable. The SOLIDWORKS has had a huge amount of increase in closure rates, and the 25% increase in the closure rate. Closure rate of what? And this is a really good slide to explain what SOLIDWORKS has done with regards to balancing out these bugs or functionalities problems into these critical versus impact. And the little red circle in the middle is what SOLIDWORKS has been focusing on heavily over the last few years. The problem is that the severity 3 and 4, which is on the fringes, is things that are working, but just maybe not always reliable, or maybe it causes instability. Those things have been growing and growing over the last 5 years, while SOLIDWORKS continues to work on the severity 1 and 2. And SOLIDWORKS has done an incredible amount of work over the last year to reduce this. And they've actually gone more than 60% a reduction of their backlog, hitting severity 1, 2, 3, and 4. And they've massively added to the reliability and quality and performance of the SOLIDWORKS by focusing on these 2 key areas. And over the next few years, they aim to reduce all of these bugs right down to 10% of what they're working on. And it's a huge commitment from the SOLIDWORKS development team to really make this the most powerful, most stable, most performing software in the world to what it is already right now. And this is really exciting and really great to see that SOLIDWORKS is listening and they are making this better and faster. In fact, it's the first year before I move on, and this is a PDF I can share with you a bit later. There's a 31-page PDF listing all of the SBRs that were fixed in this version of SOLIDWORKS. It's the first time. This is I think the 17th or 18th launch I've done personally, and it's the only one that I've seen where they actually list the number of service packs or SBRs, bug fixes that they've done in the last year in a what's new document. So if you go to your SOLIDWORKS and you go to help about SOLIDWORKS, they actually list the sheer volume of fixes they've done, which is great. So let's move straight on to SOLIDWORKS in action. So what am I going to be covering in the next 20 minutes? So I'm going to be looking at the user experience and parts. And then after I go down to edits, I'm going to be coming back with assemblies and drawings. So next I'm going to be looking at this quick access toolbar. I'm going to be doing some really cool things and the command manager and searching and improving your color options and those kinds of things. So I'm going to stop sharing this PowerPoint and I'm going to jump straight into SOLIDWORKS. So just give me a second to switch over to my SOLIDWORKS. And we can begin. Okay, so first things first, let's go and look at the SOLIDWORKS interface. Now, something small, and all of these things that I'm going to show you are for you users of SOLIDWORKS that have been using it for a while, and there's small things that you would just like to work a bit easier or have a bit of an easier way to adjust things or change things. And this is one of the things that does annoy me. You've got these gray sketches over here, and it's always difficult to see how it fits in with a model, especially with the different color backgrounds. So what you can do is go to the settings, and SOLIDWORKS has redesigned the look of the color options. So you'll see that the color settings have changed a bit, and you will notice your highlighting schemes, and I will get to the selected items now, but let's just go to the sketch. So if you go right down here to sketch and you look at an inactive sketch, you will notice that gray color. And if I just double click on that palette over there and I make it maybe a funky Lumo green color, and I go back to my model, oh, I didn't say okay. Not active sketch, there, inactive. There we go, sorry. So now I can see that a lot easier. Now, what's really interesting is that when you select seeds in a pattern, it's always difficult to understand where's the seed, when you're doing a linear pattern, for example, where's which is which, and you don't know which one to edit. If you look at these selected items, you don't know what it is. So if you choose maybe blue highlighting as a scheme, selected item number 1 is going to be maybe the root or the seed, and then the rest is going to be the pattern or the children of that pattern. So you can actually change even those colors. So SOLIDWORKS really brightens up in 2021, and you can really manipulate those as you want to, making it a lot more pleasant to work in the environment. And I'll show you some of these examples as I work now. Robert Miller from the iBow is going to be talking tomorrow. Just bragged about this massive screen that he's got. It's this huge 4K, 46-inch screen that he's got on his desk. And this 4K has always been supported, over the last 3 years, but it's been difficult to understand how to manipulate this command manager. And I want to show you a few tricks on your working environment now. So if you look at this top right-hand corner of here, you've got a little up arrow, which allows you to have a collapsible command manager. If you click on this little button ball over here, it actually collapses this side, and if you push F9, it brings it back, which gives you a lot more real estate to work in. And if you click on one of the command manager icons, it drops it back down again. But I don't know if you know this, but if you actually drag this body, this line over here under mesh modeling or wherever, if you drag it, you can actually dock this anywhere you like, and you can actually collapse this as well. So this is a really neat way of working in the command manager. So if you want to work like that, that's absolutely possible as well, and you can dock this on another screen. It's really, really handy for those guys working with large models, a large screen, sorry. And that's how we dock it back again. Again, if you see something, or if you have any questions, please go to the chat and ask your questions away. My team will be there to help answer questions as need be as well. So something that's been really great is working with the heads-up user interface. We've got this S key over here, and if you right-click, you've always been able to customize this thing. But it's been a pain to always go and find by scrolling through all these lines. New is the ability to actually have a search bar. Now, this is small, but man, it makes life a lot easier. So, if we go and say, pattern, and we go look at features, there's circular pattern, and I can just drag that onto my shortcut key. And then it will pop up in my S key. Or if I want to manipulate this heads-up interface over here, and I say maybe undo or do, there's my undo and redo. So I can just drag it over here, and you can see I've actually said open and save there as well. I love this heads-up interface here. It really is handy. I don't have to go and travel all the way there. I can just save my models and open up files by just moving my mouse over there. Now take note of this undo and redo. I'm going to show you a really cool trick later on about what SOLIDWORKS has done with the redo button. It's super, and just have a look here. So if you click on the sketch, and I use the S key for my pop-up, now I want you to take note of the workflow. And I'm going to say extrude cut. It's going to apply the extrude cut. I right click on my screen and I say through all in both directions, and then I do a right click to execute it. I'm still staying in the center of my screen. Notice that. So I want to do a circular pattern now of this feature. So what you do is you do your S key, you use that newly created little circular pattern tool, which I've just created. And then you work on the top for your direction one. You can just click a circular face or an edge. The feature is going to be the circular cut that I've just done, and I want to maybe do 3 or 4 of these. So, okay. And remember, I showed you that color option earlier on. Look at that. So again, it's easy to change those colors. If you don't like the pinks and the blues, you know where to go and change that now. But have a look at this. So if I look at this undo button over there, and I go back. Now, we've had the ability in SOLIDWORKS probably for 2 or 3 years now to go right back into the beginning where I started this thing. But if you are clicking crazy and you just click and click and click undo, you have to recreate stuff because you can't redo as much. Now we've got unlimited undo and unlimited redo. So you've got the other way. You can keep on going now and redo your way all the way back to where you started. So, yay for that. It's really, really handy having both directions. If you make a mistake, click a button. It's on your heads-up interface. Move backwards and forwards as you want. So that is the fun in the user interface environment. So now I'm going to move on to a sheet metal component. So looking at sheet metal in SOLIDWORKS 2021, we've always had the ability to do an edge flange on a curved edge like this. But the problem is always this non-planar face here. This was easy to do, but what about these edges over here? It's always been a problem. It won't allow us to do anything, and that is incredibly frustrating. So what we can do now with SOLIDWORKS 2021 is select the tangency, select the loop. Oops. Let's select the loop. Sorry. Why is this not selecting the loop for me? There we go. So now in 2021, you've got that ability to have a very complex formed part. And you can also adjust the extent of how you would change a normal flange, your flange position still there, your distances, your angles, all of that stuff is available for you to manipulate and change as you would. And what's great about it is it's fully flattenable. So although this complex is a complex part, I'm able to, stamp out this formed part. Really, really powerful new feature in SOLIDWORKS. Now, when we talk about performance, if you've got a really complex sheet metal part with lots of bends in it, they've also adjusted the algorithm or improved the speed of the algorithm in the new SOLIDWORKS sheet metal unfolding function. So if you're working in sheet metal with complex parts, you are going to see a performance improvement when working with flattening and unflattening parts. It's really, really visible to see. So here is something a little bit more complicated. I've got a flange, again, on this non-planar curvy face over here. And I just want to edit this part to show you, how we can manipulate it in context of an assembly. So I'm just going to manipulate this edge flange, and I'm going to edit the feature. Again, all heads-up interface. So I just use that heads-up display to manipulate that edge. So what I'm going to do is just flip the direction of that one, and then I'm going to change the angle to 45 degrees. And you can get an idea of how that is going to fit in context of the assembly. Really, really nice functionality to work with enclosures now. And again, flattening pretty easily. So the manufacturing technology is improved drastically. We want to go back and give you the functionality required in order to get this technology, taking use of this manufacturing technology. So really, really nice to see that we've got this ability now in SOLIDWORKS. All right, so again, I'm not going to cover all of the new features as we're talking today, otherwise we're going to be here for a while. I just want to cover all of the major highlights in SOLIDWORKS. Now, something that is happening quite often is, to use my little heads up here, I want to talk to you about 3D printing. 3D printing is becoming very, very common in our industry. So, 3D manufacturing file is something that we've had, and we've extended the functionality of this 3DMF file format. We now support saving out in 3MF format textures, occlusions, with opacities. If your file has got transparency on it, it will save it with the transparency. So if you go here to File Save As, and you save this file as a 3MF file, just go into the options, and you will see under the options dialog there to include the material and appearances. And this is something that has been requested by a lot of the guys in the 3D printing industry. So that is really nice to see. In fact, what I'm going to do is now just open a 3MF file to show you what it looks like. If I go here to 3MF, I've downloaded a dinosaur yesterday, T-Rex. And I just wanted to show you the colors. It's amazing. This is a very complex graphics 3MF file, and I just wanted to show you how well SOLIDWORKS brings in and can export all of these crazy colors and textures on this file. So really extended functionality into the 3D printing realm. So really, really handy tools to have in SOLIDWORKS now. No need to have third-party software that you have to have alongside your SOLIDWORKS. So for the last few releases, we've spoken about the structure system. And by the way, there are enhancements in the structure system. In 2021, you can go and look at it. It's a nice view manipulator. Now you can have a little graphic to manipulate the weldment profiles or the profiles. And you can go look at that. But I wanted to go back to weldments and just have a look in a little bit more detail what SOLIDWORKS has done to the core weldment functionality of the software. A lot of feedback was given to SOLIDWORKS saying like, hey, don't forget about weldments. We love this tool. We want you to enhance it. There's really, really interesting things that I want to show you in weldments. So the first thing I want to do is just zoom in over here and have a look at these two different profiles. It's a 2x3 profile. The one is a rectangular profile, and the other one is a square profile. Now, it becomes a little bit of a problem when we're trimming something like this because we've got these options to do these butt joints. But when we're doing the 45-degree miter of this, we end up having this strange scenario where you've got this massive joint because it's a 45-degree angle. It doesn't really help us too much. So what we've included is a new option in the trim extents where we're able to match the faces. So if I say okay now, you will notice that even though they are different shapes, the faces are matched in one click. You don't have to do SolidWorks ninja moves to get it to match up. In the miter function, it's an unequal angle, but it's going to match those faces up beautifully. A really quick little tip that you can take with you and use. Right, so the next thing I'm going to do is look at colors. So what I am going to do for a second, just give me a second. I just want to switch over. I realize I need to share my screen. I'm sharing my application at the moment, so if you want to just bear with me for a minute, I'm going to stop the sharing, and I want to just load something quickly. Square Robot has a website, and I need a specific color. I'm going to just share my screen quickly. Screen 1, share. Okay. So I'm going to try and do this as best I can. So just forgive me. So this is the Square Robot website. And I would like to match the color of my weldment to the website. How the heck do you do that? This is a really cool new feature in SolidWorks 2021 where we've got a button over there, edit appearance, which has always been there. Okay. But what's new is this color picker over here. So now what I can do is click and drag and move that color picker over to the blue, and it will actually map the color of the website to the color of the part. You don't have to try and get your RGB colors as right as possible. This is a really handy tool. So once I say okay, it applies the material to there, and I can then also go and apply materials to the body, say. So let's go and have a look at maybe the body I want to make of this vertical part over here. I want to maybe make these guys a orange color. So I'm going to drag over to the orange of that little triangle there, and there it makes it orange. So now if I go and maximize my SolidWorks again, and I do a little rebuild, all of my colors will be repeated in my pattern. So I like that a lot. It saves me a lot of energy and effort. I think that's a really, really handy little tool. So now that I got my colors waxed and I understand everything, I want to move over to the properties of my part. By the way, I don't know if you've noticed, I've actually taken my properties and I've thrown them into this little box over here in my tab. No matter which tab I actually move in between, it's still there. Let me tell you how I did that. So if you go to Customize now, not only can you lock that command manager, as I said previously, having another screen, you're also able to show that little quick access toolbar. Remember it was on top there? If you click at the bottom, it can move it into your, to the side panel over there. Okay, so moving swiftly along, let's go and have a look at the properties of my weldment. So good news, 2021 SolidWorks now supports equations in properties. Have a look at this. I want to look at this part and understand maybe what a cost estimate. Now in my type column, I've got equation as an option. And what I'm going to do is look at the 3 options that are there. And this was previously available when only in the equations environment. Now it's in properties. I've already created global variables where I've got the different sizes at Rand per meter. It's 400 Rand a meter and 330 Rand a meter. And I've also got a Rand, 42 Rand a kilogram. I just made up some numbers. So what I'm going to do is I'm going to say this Rand per kilogram, I'm going to multiply that by the mass of the part. So there we go. It's automatically calculated the 2 in an equation. And it's calculated for me. I don't know if did I do that properly. I don't think I did. Sorry, Rand. So make sure my num lock's on here. Multiplied by the mass. That is correct. So it's going to be 1,900 Rand, super cheap part. calculated very easily from the weight and the global variable. So what's nice about this stays as a property. If my weight adjusts, my property is going to adjust. So if I've got this property represented in a drawing as a cost estimate, and someone goes and adds something drastic to the part or changes the length, it's going to update those properties because it's calculating it live. So from a properties point of view, this is brilliant. It's also supported in the cut list. So if I move over now to my cut list and I look at these individual little plates sitting on the part, maybe I want to calculate the total length of the plates that are on my part. So let's have a look at the plates and look at the cut list property. So again, you just right click and you go to properties, and I've got the properties of that specific plate in my model over there, and it's really as easy as saying what is the total length of plate, and you go here and you say equation, and again I've got these global variables. And now what I'm going to do is I'm not going to touch the variables. I'm going to look at the properties of the plate. Look here. So I'm going to say there's 4 of them. So I'll say quantity 4 multiplied by the bounding box length. And there we go, it calculates it for me. So and I can change my units here. Maybe I was in the wrong units. So I just want to show you again. So there it's actually giving me the total length in millimeters now is 520 of that plate. That's how much I'm going to need is a total length. And again, if I go and add more similar size plates, it's going to add them up as I need. And really, really handy. And you can put if statements in here and really get creative around your property. So I think super powerful functionality added to SOLIDWORKS in the Weldments environment. And again, this is not just for Weldments. This is for anything, any properties in SOLIDWORKS. We've added this functionality. So that's the first little half an hour of the event. I'm going to now hand over the ball to Idris. Let me just go and stop sharing the screen for a second. Yeah, so that's the first bit. I'm gonna throw the ball down to Idris in the studio, and he's going to be having a conversation with Raphael from BMAC. Idris is our customer success manager for South Africa, based here in the sunny Cape Town. And we've tried to incorporate something that all of you enjoy. All of you always enjoy hosting the event. When we host the event, to actually see our customers and hear what actually happens on the ground. And Raphael is kind enough to come in here, and we've got our 1 meter social distance between them. We've ruled out with a measure there. So have fun, enjoy, have a good conversation. Welcome, Raphael, and over to you, Idris.
Thank you, Quentin. Quentin, you can confirm, can you hear us? So, okay, guys, then we are live here from our studio. So I've got Raphael Smith with me from BMAC Technologies. Can you just bring up his bio for us there, Wesley? So on your screen, you'll see there a little bit of a background on Raphael. He's a qualified aeronautical engineer that mastered in biomedical field. And currently is the managing director of BMAC Technologies, a company that specializes in engineering consulting, bespoke engineering consulting. And what I've seen is actually making the dreams of people come true. So I'm going to hand over, Raphael. Thank you for joining us. Welcome to our studio here. So you can take us through your presentation and
Great. Thanks for having me and giving me the opportunity to come and chat some SOLIDWORKS with you guys. Yeah, so let's have a look at this slide here. If you guys think that looks like a bucket of blood, that's because it is. So basically, we have a very firm policy at BMAC Technologies of taking on any project that comes through the door. So a couple of years ago, we had what seemed like a pretty tame project come through the door. We've had a lot of talk of tinfoil and hidden energies, but this was a simple project. Somebody asked us to make a pump. So yeah, we jumped at it. We can make a pump. Well, it turned out that pump was to pump fake blood around the cadaver. So that's a dead body that surgeons use to practice their surgical skills on. And it turned out to be an amazing project. And to this day, we're very involved in that. And we have pumps all over the world. And we provide that service to all the universities around Cape Town.
It's one of those things that we don't know about the medical field that goes on, but quite amazing, yes.
Okay, so like I said, we pride ourselves on taking on any projects that come through the door, and as a result of that, we have a very broad base of expertise, and we really specialize in putting all of those things together. Although we do projects with individual components of that. So this picture kind of encapsulates a lot of the different things that we do. You can see there's a circuit board or PCB, and we do electronic and PCB development. You can see there's a couple of mechanical components. So we do design and manufacture of mechanical components, and everything from bigger agricultural equipment all the way down to microscopic surgical instruments and implants.
I see there's a cell phone in the shot as well.
Yeah. So on top of that, we also do mobile application development and web application development as well as the full stack of back-end servers and all that kind of
stuff. So you do start to end full solution for the customer.
Full solution, and we love pulling all those pieces together when there's a circuit board and a mechanical element and a cell phone app, and they all talk together, and there's dashboards. We love those kind of projects.
Brilliant.
Yeah. Okay, so this is one of my favorite projects. Basically, it's a surgical instrument that's used to move somebody's eyeball out of the way so that you can get access to the optic nerve that's behind the eyeball. And there's two things I really like about this project. First of all, the instrument itself is beautiful. So we do this kind of very bespoke manufacturing as well. So you can see it's a highly polished surgical titanium instrument that's been CNC milled from a nice big chunk of titanium.
Yeah. Now, a lot of the guys watching this say, "No, man, I can design that quickly. I do stuff like that." But you had to balance out to come to that specific shape between different actual eyeball sizes, and just take us through.
Okay, so I think that's one of the key challenges with medical work is there's a lot of very sophisticated 3D models of the human body out there, but the problem with that is that no two human bodies are the same. So far as to say, my dad's actually a surgeon, and they once opened up a patient for a procedure, and everything was on the opposite side.
Yes.
So these crazy things happen. But this instrument, we had a drawing from the surgeon who invented it. And basically, we knew that it was never going to turn out to be what the drawing the surgeon brought to us. And so we very carefully and meticulously made sure that the way we drew this instrument was very adjustable. So every sketch was carefully planned, and every feature was carefully planned to ensure that we would be able to make the changes that we anticipated based on our experience and our understanding of the medical environment.
I just want to add that point. Anybody who's had essentials training from me, I don't know about Raymond sitting there at the back as well, but I always preach in chapter 1 of the essentials manual, there's a little paragraph that defines design intent.
Yes.
And it says that's the way a model should behave when changed. And that is what you guys thought of very carefully here, is building all the parameters in to allow yourself the ability to change this and adapt this as you go.
Yeah. And basically, I mean, I happened to open the model yesterday, and we're on revision I. I don't think we've ever gotten that far before. So yeah, it's taken a lot of revisions, and that's because the reality of prototyping this is that design for manufacture is another important aspect. We need to be able to 3D print this, but we also need to be able to make it from titanium, and long term we'll want to stamp it as well. So all of those things are taken into consideration. But yeah, the point I was making was about basically, in order to validate each of these designs, we actually have to go and do a cadaver trial on each version. So this is not a case where you can run down to the workshop quickly and plug it in or run a test on a bench system. We actually have to go and do a mini surgical procedure each time to make sure that it's doing what we want it to do.
Wow. So you're going to actually show us this in action. So
yes.
We're warning everybody, please, all sensitive viewers, look away. We'll tell you when you can open your eyes again. Raymond's closing his eyes there. Show us this in action, guys. So
everyone's eyes closed.
Brace yourself.
All right. So this is the reality of what it looks like when we test our designs. So what you can see here is a patient, and they've got the instrument inserted as it should be. For those of you who are very squeamish, please block your ears for the next 10 seconds as well. So you can see in the pictures that there's actually stitches that go into the muscles on the eyeball. So they're used to rotate the eyeball round. And then our instrument is inserted, and that makes a space that allows the surgeon to get access to the optic nerve, which comes out the back of the eyeball. And this is a novel instrument. It's patented, and there's nothing else out there like it out there in the world. Previously, there would be a whole bunch of instruments and assistants and everything pulling everything out the way. Here you can see the surgeon himself has complete control over the instrument and what he or she is doing. And the purpose of this procedure is not actually the rest of the system that we've designed, which is a patented implant. Here they're doing something called an optic nerve fenestration, which is if you have a buildup of pressure in the area around your optic nerve, what they do is they go and they make a small incision in that sac, and it releases some of that pressure.
Some of the pressure on the nerve. Quite interesting.
Yeah.
Cool. I think let's... Guys, everybody, it's safe to open your eyes. If any of your colleagues maybe fainted at this stage, quickly take a picture, post that picture on LinkedIn, tag @MECAD Systems. Who knows? Maybe you can win something for that if you've got a good picture there. So hopefully everybody is still with us there. Excellent. It's just amazing to see something like that in action. I think you must actually feel quite proud to see an instrument like that where you know what's gone into the design in action.
Yeah, I mean, we love this project. It's part of a bigger project, which is a surgical instrument and implant, permanent implant. And like I said, that's a micro-molded component. There's like a 0.2 inner diameter. It's tiny. And that's actually for the treatment of glaucoma, which is one of the leading causes of blindness. And so far, it's in early clinical trials. It's looking like it's cleaning out and doing way better than any of the other options available. So it's amazing to be involved in these kinds of projects. Yeah.
Cool. What have you got next?
Okay, so this is basically, well, I guess there's no audience here, but maybe you guys can guess. Somebody shouted out. Yeah, everyone can tell this is the Recline Trike. Nothing new about that.
So this is not a medical.
This is I don't know where would you implant that?
No, I thought initially it was a type of a wheelchair, but it's not. So no, take us through and explain to us what it is.
So basically, this is a Recline Trike, and it's got power assist. The reason I've chosen to share this model with you today is it's a really big model, and it's really detailed, and it's a great example of using CAD properly.
Just before we go into the actual discussion of that, just show us what the full model just into perspective for people.
Okay, great. So basically, the trick with this is that the seat can go flat, and it's actually a tent. So we were approached by a client from the US, where this kind of touring cycling is a really big thing. And he had this idea, and we helped him get a patent for it, which was a touring bike that you could just camp in when you got to the end of your ride for the day, kind of thing. So it's a crazy project, but it was a really great one for us to take on, and yeah, it's quite a cool one.
Okay, let's go back and discuss a bit. We had an interesting discussion. Wesley, you can bring that up for us again, full screen, the bike, just so that we can see the detail that you modeled here. And I just want to talk about the design philosophy that you employ in your modeling, in accuracy in design.
Right. So yeah, basically this model has a couple of hundred components in it. And this is a really great example of the way that at BMEC Technologies, there has to be a really, really good reason why we don't include something in the CAD model. You'll see that every cable is in there in terms of the brakes. This is actually an electric assist bike, so all the electronic modules are included on the back wheel. You can see there the motors. The chain is CAD'd out in detail, and everything, of course, is completely dynamic. That was really important to us for a couple of reasons. First of all, this is a steering system, and while we can build a model of that, which interestingly we use SOLIDWORKS Sketch to do as well,
okay.
Your model can never exactly match the detailed 3D picture when you have to add in all of your fasteners and spaces. It always tweaks things a little bit. So we use our final design as our steering model. And we use a lot of parametric sensors and all of those kind of things to compare what the steering performance is in terms of Ackerman angle. So for those of you who may not know what that is, when you have a steering system, your wheels don't actually both turn the same amount. Your inner wheel needs to turn slightly more than your outer wheel. Otherwise, you won't actually turn, you'll kind of skid along, all right?
Yes.
So it's very difficult to achieve the correct angles 100%, but you want to get it as close as possible. And so that's where all of this comes in, is that we can see the error in those angles and make sure that this thing is actually going to steer before we even put it on the first prototype. Funny story, I learned my lesson with this. Many years back, we built a box cart for the Red Bull box cart racing. We also drew that in SolidWorks, but we didn't pay due attention to this situation, and this thing, needless to say, didn't steer so well. So yeah, I think that, and then in terms of going through the work of modeling out the chain and making everything dynamic in a system like this where everything moves, it's very easy to assume that you've made enough space for the pedals to turn around, but you probably haven't. So we by detailing every single component, we caught so many places that we would have had to whip out the angle grinder on this project, which is not something you want to be doing on a finished thing.
Yeah, you actually mentioned that a few times where a lot of people go for prototyping and say, we fix it when we get there. The small things like routing a cable, attaching something small. Where we said, no, let's model everything, do that. And what I gathered from that is actually by identifying problems quite early on, then you actually feel that your design becomes much more intuitive because you're interacting with the problems and you're coming up with really good solutions while you can still handle the impact kind of that in your model.
100%. So there's kind of two extremes to design. The one where we like to think we are is in modeling everything, and the other one is in sort of building everything by hand, artisan style thing. And that's great, and artisans do an amazing job. The problem with that is what we do is we design turnkey solutions for our clients where at the end of it, they're expecting to receive a manufacturable product. And your role of your artisan, if they're designing on the fly, that knowledge is with them, and we can't hand that over, kind of thing. And it's a big problem for companies as well to have their information so tied up in an individual. So we we play the role of that artisan and we involve them in that process as well to make sure that we've considered all aspects of design and design for manufacture and production at this point. And, we use the SOLIDWORKS tools extensively with that, especially your exploded views. We reverse assemble everything with your exploded views. How is this piece going to go together? At what stage of the assembly process is it going to fit in? And we do some really cool things with that. We'll pick up, hey, listen, the guys might get confused by these two fasteners. We should put in a design feature to make sure that they don't put in the wrong one and so screw it too far and damage something. It might be difficult to align this up. What's the welding jig going to actually look like? Hang on, we can add a little feature here that's going to cost 1 cent worth of laser cutting and avoid having to build a 20,000 Rand jig to align everything perfectly. And, so this model comes together jig-free. This whole bike comes together jig-free. So all the laser cutting is puzzle pieced together so that it'll all come together without a jig.
Yeah, I think that interesting enough, that is something that I've picked up with a lot of people with laser cutting, starting to key basically pieces together. And it's improving. I've seen some of the before and after machines that was built without that versus the ones that's now been built with this, and the quality of the build is far neater. It's brilliant.
Yeah, no, it's amazing, and I think if you're not doing that in your designs, you're really missing a key opportunity.
Yeah, something that I said to you that. So what you are saying is that put in the extra effort and time in your modeling and you reap the benefits down the line. But you actually said, no, it doesn't take more time. It's a mind shift.
Yeah, it is a mind shift. I firmly believe it doesn't take more time. The thing is that it's easy to, and I think that's where it comes in, that we do everything in-house, is that it's easy when you have distinct engineering and manufacturing departments to try and minimize everybody's individual time. But when you look at the bulk cost of that project, you are definitely adding time when somebody's going to have to whip out an angle grinder and a welder and ship parts backwards and forwards and refinish things. You are definitely adding time. And we had a project recently where one of our clients, in fact, does this sort of freestyle design approach, and they weren't sure what the hydraulics were going to be or where the lines were going to run. They repainted this machine at least 5 times. Everything has splatter all over it now. And there was a lot of, that's not going to fit.
Yes.
So yeah, it definitely doesn't take longer. And I think just from the perspective of the time it takes to do the CAD, it also, we're not slow at CAD. We don't take forever to do a model. It is built into our procedure. We do it from the beginning. And as you say, it's just a mindset to say, I'm drawing this part and all the details are going to be in it from the beginning, and it works out.
Yes. Now, you said something there that we spoke about, your procedure.
Yeah.
You've established a very specific way of drawing that you enforce through everybody in the company. And you said that actually makes it possible for anybody to work on one another's files.
Yeah.
So let's move on into how you employ SOLIDWORKS.
Yeah, okay. So to give you guys some idea, if I haven't already made that clear, of how important or how much of a role SOLIDWORKS plays in our organization. This is our logo, which we drew when we founded the company in SOLIDWORKS. Okay. It's good because now we can stick it into all of our parts with ease, and we're not busy trying to convert from Adobe Illustrator.
So SOLIDWORKS has been part right from the beginning.
Exactly. Okay, so I've kind of already mentioned this, but a long time ago, I worked with a very, very talented engineer and a great draftsperson, all right? But he had an issue, and his issue was that every time we made something of his, we tended to have to do a little bit of rework on the final product. And by rework, I mean an angle grinder and a welder at 2:00 in the morning in a puddle of spilt milk. So, yeah, things can get pretty bad. Never underestimate the consequences of a blue circle in your sketch.
Okay, so you referring to a guy that did brilliant design, but he didn't fully define his sketches. He left things open and so on.
Yeah. So I think that kind of brings us to this topic of discussion, and that's that for me, it's a simple feature, but one of the most powerful things about SolidWorks is being able to tell that your sketches are fully defined and things aren't floating around, because that's exactly how those mistakes would happen, is that there would be some undefined features in the model, and basically when you build that into an assembly and then you start editing parts in assembly, which is an extremely powerful tool, you are prone to accidentally making unintended links between things or shifting something unintentionally, and it's really important that you don't have that.
You actually use a big base sketch with a lot of information in it.
Yeah, so that's one of our key features of our drawing standard, is that and you mentioned this earlier, and you guys saw the end effect of it with the surgical instruments, is that it's critical for us that within our organization, and when our clients take on our drawing packs that we produce for them, they're able to open up a model and understand it. We can't afford internally or externally for someone to have to spend 2 or 3 hours getting to grips with each part in a big assembly. And more importantly than the time it takes, if your designs are complex and there's nested dependencies, somebody's going to try and change something, and they're not going to be necessarily aware that they've made
the effect,
that there's a knock-on effect into something else. That said, there's the great features in SolidWorks where you can actually see your parent features and all of your children features as well. We use that a lot, but still you can't tell just because it's a child if there's going to be a knock-on effect to changing something like that. So what we do in our drawing standard is we try and get as much information as possible into base sketch. So your number one sketch. And this is a great example of that. It looks messy here because I've zoomed out, but and all of the sketches are kind of scaled proportionally. But when you zoom in, it's very neatly organized, and you can clearly see what each component is dimensioning. And what you'll see here is, for example, when we're drawing a sheet metal component, we don't draw the base part and then add a flange and then make another sketch and then add features onto that flange. We draw as much as we can in that base sketch, and then we use sketch bends to bend up those features after the fact.
Okay. Interesting method.
Yeah. And that served us really well. We've done some really complex sheet metal design, and that's an amazing feature for us. And you might say, look, how do you get your distances exactly right? Well, that brings me to the next benefit of this, which is that in assembly mode, then you can double click on any part and adjust that feature. So you can easily measure the difference in distance between where that feature is and where you need it to be, and just double click on the model and add that into your dimension right there and rebuild, and it's all sorted.
The one thing that I do want to take from you as what you said, that you stick to a specific procedure, and everybody follows that. And I think that for me is one of the biggest messages. Don't just give it over to everybody to come in and do his way of modeling in a company. You stick to something that gives you data integrity for your purposes. And that's quite, and something interesting we said with the parameters in the medical field. You have to be able to prove that something moved a millimeter left or a millimeter right or bigger.
Exactly. So that's that's one of the big problems with your sort of push-pull design style packages is, for our applications, whether it's medical or anything else, it's not really acceptable to say, we made that a little bit smaller or this a little bit bigger. We need to be able to reference a specific change. And, with that parametric style drawing, we can open a dimension, we can number it if we need to, and say we change this by 2 millimeters. And we know exactly what the consequences of that will be. And our clients can also say to us, listen, guys, we need to make this bigger. And we can open up the sketch and say, okay, it's defined by this. How much do you want to move that over? And, 2 or 3 millimeters.
It allows you clear communication.
Yeah, exactly.
I just want to go into your next slide. Using renders as well, as soon as that's up full screen, you guys will see on the left-hand side the render and the right-hand side the actual product, photo of the actual product. And you make use of this quite often as well.
Yeah, so look, this is actually quite an old render, but it gives you a good idea of where we were even 5 years ago, kind of thing. So rendering is extremely important to us. It's a critical step to selling most of our products to our clients. This helped us sell this project, and these boxes are all over the world now doing what they do, which is replacing chlorine with ozone in food processing environment.
You made an interesting remark on this, that when you showed this to the customer, you actually picked up something in the materials.
Yeah. So obviously in the modeling environment, it's not always easy to tell exactly what the materials are. And you can see that the hinges on the render are slightly different to the hinges on the final product. And this render actually gave the client the opportunity to pick up that these were powder coated and that wasn't going to be suitable for the highly corrosive environment. So, that catch there was of extreme value. It saved us design time of putting out the wrong thing. It saved us a lot on production time as well. We would have manufactured that, and again, welder, angle grinder, 2 in the morning.
Exclude that. Yes.
Avoid it.
No, brilliant. Guys, are we looking on time? Yeah. I think, time flies when you're having fun.
Yeah.
We've got a few minutes left. Just to, I think if you go on to the next slide, this is something you want to show us of what you've been able to do with SolidWorks.
Yeah. So I think just to touch on how important renders are, this is an example of a render that we did of the eye, and it's beautiful for starters, and it's great to be able to create this kind of content. So that comes back to my point of don't ever assume that a particular type of modeling is the domain of a non-parametric modeling package. We do it all in SolidWorks, and we think that we don't do it because that's where we're comfortable. We are comfortable with the other packages, but we do it because it's parametric and everything is well defined there.
Yes.
And this was actually used extensively in that ophthalmology project, basically to demonstrate the device. It went on to be used in animations. And long story short, this model, helped that project secure many millions of rands worth of funding. So
that's brilliant.
This is photo view.
You're just bragging a bit here. This is still. You actually mentioned this is still photo view. Not even this was done before Visualize.
Yeah.
So no, excellent. So I think you can put us. I think the next slide is your details. If you guys ever want to catch up with BMEC and maybe make use of their expertise, there's their website and their info. Or contact us. We can put you in contact with the guys as well. So very interesting fields. Thank you very much, Raphael, for spending the time, taking the time to put together the presentation for us.
Yeah, thanks, guys. Thanks so much for having me. It was a great opportunity to share. I hope everyone enjoyed it. It's kind of weird not having any audience here. Feedback. So let's get some likes in the chat or on social media. Yeah, you guys can have a look at our Instagram here if you want as well. There's some really cool pictures of all of these projects and a whole lot.
Excellent. Thank you. Quentin, I think you're joining us. We're going to hand over to you. So
super.
As soon as we see you in there.
Okay, brilliant. Thank you. Yeah, back up to me. Thank you, Raphael. And I'm gonna continue from my side. And I'm gonna share my screen for a second. I just want to show you what's been going on social media. Let's have a look. So again, thank you guys for those of you who are posting stuff on LinkedIn. So again, just to remind you, at MECAD Systems, hashtag MECAD Systems, and just talk about what you're up to. There's some really nice photos of people in their office watching the event. Really, really cool. It's so nice. We can't be with you guys, but we can at least see you guys in action. So and there's so many of them. So thank you. Keep it coming, guys. Really enjoying seeing you posting live. That's really fun. Okay, so we are well on time. I'm going to now switch back gears to SolidWorks. And let's get going again. I'm just going to share my screen. and I'm going to share a screen for a change because I'm going to be moving in and out of SOLIDWORKS. So this is just some delight, as we call it, in the assembly environment. So I'm going to just show you a few things that's been updated in SOLIDWORKS. Let me zoom in here a little bit. Now, if I control select these two faces and I go to the mate tool, you will notice on the left-hand side that the mate environment has been updated. These tabs now have been included. Previously, you'd have to scroll and scroll and scroll and have all these, long list of things that you could do, and they've just added so many tools to mating that they've now got little tabs, which is so much easier to manage between the different environments. So one thing you would have noticed is that this screw is on the wrong side. So that is a bit of a problem. So let me show you how we fix this. And this is a common problem. So that washer, and you should know this as well, but in your feature tree, there's actually a mates folder which you can access from the tree. So if I go there, I can flip the mate alignment just like that, and it moves it completely around. But sometimes, and don't worry about this, just a read-only file. Sometimes when you do that, you get a message that comes on your screen like this that says, this change will cause mating errors. Do you want it to continue? Now, I want to see in the chat, those of you who have had this message and you said no. Now, when you say no, all hell breaks loose and your feature tree goes crazy and you realize, oh yes, you should have put yes. Yes was the right answer. Yes is always the right answer, but sometimes you want to intentionally break it, but 99% of the time you want to say yes, because what it's going to do is going to flip the alignment of all the other mates that are involved there, and you'd have a lot safer environment. So how do you make it always yes? Well, there's an easy answer to that. So what you can do here is you go to the tool, your options, and there's actually a setting for that now, and I'm going to show you that. When you've got mate alignment, always just say yes. So that's a little setting that will just make your life that much easier. So, again, just go and have a look at that tool. Look how it flips all of the mate alignments. So much easier if you've got that down, just a little trick for you. So I'm going to throw you some little tips and tricks here in between the event. Another really cool tip is that if you are working with a slot and a circular face in the pop-up, you've got the slot tool. Now, by default in SOLIDWORKS, you can actually set what type of slot you'd like. I've just put that in the center, and I've locked the rotation for those engineers that are OCD, that don't want that thing to rotate. So just a click, a right click, and we are done. So that slot is now locked in place as well. And ironically, there's a setting for that too. So you've got options in SOLIDWORKS to have in mates under your document properties, and you can actually have things like misalign mates, your default constraints for your slots. You can even do that as a document property, so you can always have it like you want it. So something else that I'm going to do is look at this left-hand side, and you will notice that I've got this pattern over here, and remember those color selections I showed you earlier shows you the seed component at the bottom. Now, what SOLIDWORKS allows me to do in the past, it allows me to adjust the size of each individual instance of that pattern. So although the seed or the root of that pattern remains the same, the rest I can change, which is sometimes a massive problem. So what we've allowed SOLIDWORKS to do in 2021 is to actually lock that. So what we're going to do is synchronize all of those components to the seed. So no matter what you do now, it will always be consistent. So you can either have the flexibility of having control over the configurations of the pattern, or what you can do is drive that through the seed in the pattern. So just something that is really nice, and you are not able to change anything anymore. So a really nice little trick there for you to do as well. Something that has always been a problem is the communication of interferences. So when I've got an interference check on a small subassembly like this, it's quite easy. But how do I communicate it? So what we do is we're going to go to the interference detection and have a look at the interference detection tool, calculate it. Nothing here is new. But for those of you who don't know, there's a little fasteners folder here for all of my fasteners. And I'm actually going to choose to ignore those because, you know, I understand that there will be some of the tight fits, you know, with my fasteners. I'm going to ignore those. I don't want to report on that. So what this allows me to do now is to have a save results button. So if I say save results, I'm able to take this and I'm just going to save it out. And there's a thumbnails option there. So if I save this out, SOLIDWORKS is going to go and take a snapshot of each of those errors or interferences that I've got in my model. It's going to put it on a really nice Excel spreadsheet for me, and just right click there to say thank you. And if I open up the Excel spreadsheet, it looks like this. Shows you the different interferences. It shows you the image of where it's interfering, how much volume of interference there is, the components that are interfering, and just a full reference of where you can find that. So if you're going to share this, have a meeting review, you can at least have a complete, comprehensive idea of what's going on, and you've got a roadmap to work with. So really, really nice to see that. Right. So I'm going to shut this down, and I'm going to move on to my sim performance. Oh, yeah, while we're here, this is something nice as well. We spoke about, Raphael was speaking about a chain, and we've always had this little chain mate in SOLIDWORKS, which is really fun. I think about 5 years ago they brought it in. It's really powerful. What they've done in the new version is they've added this linear distance or distance along path option for you to choose from. And I've just put a dimension between, you know, the start and the end of each link over here, just to show you the dynamic movement if I actually have it, you know, to measure along the distance of the path. And it's interesting to see as I change this and move it along how the dimensions actually change. So if I push this along, you can see it's measuring. It's keeping the distance along the path and not a linear distance. And it's really, really powerful to have that flexibility without having to do SOLIDWORKS ninja moves in order to get it right. It's a tick box now, and you've got the functionality. So really nice little trick. So performance. You know, I was bragging about that earlier on, and I'm just going to move my screen over here. Give me 1 second. I'm going to share something with you, which is the performance difference between SOLIDWORKS 2020 and SOLIDWORKS 2021. Although the functionality for the performance pipeline was in SOLIDWORKS 2020, it's now on by default in all of the versions of SOLIDWORKS. So you will notice that if you go to Tools and Options and Performance, that's Enhanced Graphics Performance is a button that is on. And what I'm going to do is I'm actually going to go to the software, big marker, and I'm just going to launch a poll. And it'll be interesting for me to see, for those of you, Wesley, don't you want to just go to the poll quickly and launch the poll for me on the performance pipeline, please? I'd like to just see people's response and who's actually tried this. So this is a complete rewrite of the code of SOLIDWORKS using OpenGL 4.5. And this is 2021, same software, same hardware, with the option on versus the option off. And again, this option is going to be on by default for all of you, but it's taking the workload and shifting it off of the CPU and handing it over to the GPU. So, you know, the performance difference is massive. The same hardware, same graphics cards, and you can look at the times. This is a macro that ran. It did 50 mouse moves, moving around, zooming in, zooming out. The one on the left with enable did it in 7.9 seconds, and the other one did 161 seconds with a frame rate of 63, which is incredibly fast. And really, when you put that on and you work in SOLIDWORKS with even an assembly like this, which is about 2,500 components, it's a huge difference. You can feel it immediately as you're working in this environment. So, you know, I'm encouraging you to really, you know, get a new graphics card if you haven't got it in the last 5 years. Generally, those with supporting OpenGL 4.5. So it's all of the graphics cards over the last 4 years. If you've got one of those, you're okay. Just update your drivers, and you're going to take advantage of that. So this is hidden lines removed, hidden lines visible. You know, we just changed that so we can see the silhouette edges. And you just want to see the massive difference in frame rate working in 2021 with an option set on versus not, and it really handles this this complex amount of edges so well. And again, it's just because SolidWorks has shifted that workload off to the GPU, and the GPU is doing most of the work. Your graphics card is working overtime now, which is fantastic news. And we can see a huge performance jump in SolidWorks. And that is really on graphics, just the usability, the feel of working in the software. It's really clever stuff. They've used a thing called occlusion culling, and as we rotate this model, it's something, from that's why I'm playing a video. This is not available to you, just for us to show you what's happening. This occlusion culling is a bit of technology where they remove areas of the model that you can't see. It doesn't render it at all. Doesn't need to. You can't see it. So previously, SolidWorks used to render everything, even if you couldn't see it. And now with this occlusion culling, it does a bit of clever work in the background where it doesn't even render the stuff that you can't see. It's irrelevant. And SolidWorks has done a really good job in getting that working faster. So really cool, really works. We've opened up tons of large assemblies, and it's really fun to see. I was at a customer a few months ago, and just before lockdown, actually, in 2020, or was it 2021 beta, and asked the customer to sit down behind the laptop, and I loaded on their machine, the SolidWorks, and I turned the option on, and I opened up their largest GA that they had, and one of the guys sat down and rotated around, and he didn't have any expression on his face, and I said, why do you look so neutral? You're not excited about anything. He said, well, I honestly can't give you any feedback. I've never been able to open this assembly on my machine before, so this is completely new to me. So this is amazing to see that on a normal machine, and this was a 5-year-old computer, it was just taking completely advantage of the new tech. Really exciting. So if I just go and say file open, and I'm going to open up a top level assembly. Now this is the main the top level robot that I'm going to open up, and I'm going to do this stuff live. I'm not going to do videos, and I'm just going to open up this in lightweight. So even opening files is faster in SolidWorks 2021. They've actually ported this back into Service Pack 2 of 2020 SolidWorks, the one you have now. And the drawing performance came in Service Pack 5 of SolidWorks 2020 as well. There's backporting on some of these performance improvements in the software as well. And this is a 2,500 component assembly that I'm opening up in lightweight mode, not a quick design review mode. I'm opening up this assembly in 27 seconds. It's very fast. And you can again see, the performance of this thing live. It's really snappy and really quick. So at 27 seconds, I've opened the assembly. It's in lightweight mode. And it's really nice to see. So 2021 Service Pack 0 is already available, by the way. Something else I want to show you, which I thought is really clever. What SolidWorks has done is they've loaded this in lightweight mode, but you'll see some of these are already resolved, and you may be asking yourself why are some of these resolved already? The reason is a bit of new technology, a new feature they've added. So if I maximize the part or the subassembly, it automatically resolves those. You can see here's all the features now. And if I go to this one, you see there's a feather there. And in previous versions of SolidWorks, if you click that, it's normally just a plane. There's nothing there. So now what it does is it intelligently loads what you need. So if I need to edit this washer and I maximize that, there's all the features that I need to edit. And it leaves everything else unloaded because I don't need it. Very clever piece of coding by the SolidWorks guys. I think that is a very smart idea. So what I'm going to do is I'm going to open up this subassembly at the bottom and open that up. Okay. Now you'll notice that the screen's jumping on the left. Do you notice that? On the left-hand side, it's jumping and it's taking long to open. This is a small subassembly. There's a few components over there. Don't worry, this is not a bug in the new version of SolidWorks. This is a common occurrence with our customers, and we have this strange looping effect, and then we get called and say, your SolidWorks is broken, and this new version's terrible, and what are you doing, and why is it taking so long? And then the tech team goes in and has a look at the files, and we find a thing called a circular reference. But it's always very difficult to understand, where is a circular reference? What is a circular reference? A circular reference, if I can simplify it in a way, is an in-context design part that references each other. So you use this part to create this part, and then you make a hole in the one, and then you use the hole on the new part to define. It goes in the circle, so it solves itself round and round, and it gets crazy. And that's why SolidWorks, jumps up and down in the tree. It's confused. It's trying to solve the one before it solves the other, and it goes in a loop. We call it a circular reference, and it's a massive, massive no-no in any parametric design system. But how do you find that? Now in SolidWorks, if you've got a dodgy behavior in a part, what you do is you go to your performance evaluation. It's going to tell you exactly, I've got previous versions of this file. It was modified then. I might have some graphic issues to look at. I've got statistics over here to have a look at. I've got performance settings, and I can actually have a look at the the settings over here to see what's actually going on. There we go. So it's going to tell me under my rebuild performance, which is what I showed you earlier, that these files have circular references. Now I've got a nice little pop-up that tells me, so sorry, Quentin, you've got these two holes, hole 2 and hole 3 in these parts. It's got reference edges even, and it's telling me that these are the guys that are causing the problem. And you can actually go and print it out and copy it and then save it and go and have a look where it is. But for the convenience of demo, I know exactly where they are. These are the two guilty parts. And if I go and isolate these two guys, we can have a look and see what's going on here. So this is the two part. These are the two parts created in context of the assembly, which is great. But I've got a hole that was created. And if I go and edit this part, don't worry about the error message. It's just because I'm working with a read-only file. If I click there and I say edit the feature, it's using the hole in my hole wizard as normal, but I'm using the position of the other hole to create this hole. Great, nothing wrong with that. The problem comes in when I look at the part, the gray part, the light gray part behind this one. I've then gone and made that hole also in context and referencing this hole. So someone in the design team went and referenced this sketch to the hole. So can you see the idea of having this infinite loop? The one is referencing the other, but the other one was actually created before the other, and it becomes an absolute mess. So what you've got to do is you've got to go and delete these circular references, and then just use your normal dimensioning tools to place these guys in a position where they are going to just be satisfied with normal dimensions. It's just so much easier to use this than crazy dimensions. Now I want to show you something while I'm here. You notice that the dimension color is a more dull color. So in the new version of SolidWorks, they've actually made the dimensions a softer color so that you can actually place the dimensions and not have them interfere where you want to place them. So it's just a clever little trick that they've done. So now that I've placed my model, I've got all my dimensions fixed up, I've broken that, and the circular references are now gone. So much easier than having interconnected errors with my models going in loops. So now I want to show you something really interesting. I've got a problem where this part is really massive. Now, in the past, we've had a tool called the D-feature tool. If I go here to this bush roll, okay, it's a complex set of parts, but I don't necessarily want to have I don't necessarily want to go and have all this detail in my part. It's completely unnecessary. It's going to create a lot of work for me downline. I want to de-feature this, and a lot of you have used this de-feature tool. So I did a quick rebuild there now. You see top level rebuild. Everything's happy. It rebuilds quickly. No problems. Everything's hunky-dory. Okay. So if I go to my assembly and I see the de-feature tool, you can also go and search for that under de-feature. Okay, there's de-feature. So de-feature basically removes detail from my complex subassembly. Maybe it's proprietary information I don't want to share, but this subassembly is required for use in for maybe one of my suppliers or my customers, but I don't want to share my information with them. They just need to take this and put it on their model. So we use de-feature to do that. So I want to show you some of the tricks on how to use de-feature, as well as some of the new tools that are available in de-feature, and it's really, really easy. Look how I de-feature this complex subassembly here. So all you do is you just say, next, and I'm going to go and start group 1. And you just select in the model itself, the components you want to add to individual groups. And why I'm doing the different groups is because I can control them individually. So now some water. So I'm going to have the front plane, and I just say add group. So what it's going to do now is I'm going to split my screen into two. I'm going to look at my original model, and then I'm going to look at the result. So as I'm creating my D feature, I can look at the result live, which is very handy as well. So let's keep on going. Let's look at the shaft at the back here. So what I'm going to do is just select on the shaft, and I'm going to say just a cylindrical shape. So say cylinder, and pick on a plane so it orientates it really easily, and I just say add. That's going to add it to my group. I keep on going. I'm now going to take these top plates over here, this one, this one, this one, and that one. And I'm going to choose a polygon outline for that one. And I'm also going to enclose them into one body. So I just needed to represent it as one body, as a polygon. I just needed to represent the top part of that, and it doesn't need to be super detailed. I just need it like that. What I can also do is look at my feature tree inside of my model and look at this bush roll again. I can select an entire subassembly set, and I can do a polygon outline of that. I can also do the same and close that into one body. Orientated with a front plane again, so that it knows which way to run, and I just say add it to the group. It's fine. Give it a few seconds, and it throws it onto the screen. There we go, looking good. Let's move to the back end of this model. So I'm going to now do something a little bit more detailed, because these bearing housings are important for me to have done correctly. So what I'm going to do is I'm going to say none. I want you to do that, or I can do a tight fit outline. It doesn't really matter. You can choose. I just want to show you the example. Maybe I'll do a exact model in the next one. So place it on the front plane, and I just say add group again. And you will notice that it's going to apply that to my model on the side. Lastly, I've got these very complex plates over here, and this one here, I'm going to copy it completely. So I'm going to go here and say none, copy the geometry as it is on the front plane, add it to the group, and there we go. Okay, now I'm done. I say next. What's new in 2021 is the ability to create a configuration of that. Okay, now why I love that is that you don't have to have two separate files and you've got to replace them, and it was just a mess always to work with these different file sets, because sometimes I just need to simplify the geometry. There's no changes in the model at all. It's just a simplified version of what I have. So while I'm talking about performance, there's the simplified version. If I go to the configuration in the tree, you will see that I've got a default version. The previous versions of the other configurations are still there, but you'll see a additional configuration underneath my default. And if I double click on default, it's back to default. And if I go to the D feature, it's there. Did you notice how snappy it was changing configurations? That also in SOLIDWORKS 2021 has been improved. So switching between configurations, switching between models has all been updated. Now, if I go and Control Tab back to my main level assembly, I want to show you how we can use this defeatured subassembly in my top level assembly. And because it's all integrated into one configuration environment, the intelligence is built into the subassembly itself, and I don't need to worry about creating these external files, which was always a problem with defeature. And this is one of those tools that's been greatly enhanced for usage. If you see that my part is fully loaded there, now I can right-click on it, and this will actually allow me to. Sorry, my eyes are not great. Use defeatured. There we go. So there's use defeatured. You can see it there. So what it's going to do is going to switch the configurations for me. I don't need to go in and right click and go to configurations and default. I don't have to do anything like that. Immediately, it's going to load that basic version of my subassembly. Notice that all of the mates are still there. There's no issues at all. It's very happy for what I've done. And you can see the icon in the tree. It's changed there. Very, very, very nice. And I can update that, or I can set it back to parent. And within a few seconds, that thing's switched out. So the switching between configurations and working with complex top level stuff has never been easier. So very nice, very, very happy with what they've done in SOLIDWORKS. please go and make comments, and I'd love to hear what you guys have got to say about this. And please give your feedback as you guys start installing SOLIDWORKS 2021. We'd love to hear from you guys, and if you have questions, continue to engage with us, because we're really excited. So lastly, I'm going to do drawings. So again, performance. So I'm just going to close everything down, and I'm going to open up a detailed drawing. So a detailing mode or detailing view is something that was around last year. But the problem with it was that it was a start of a really cool, really useful tool, and it was half-baked. I think they brought it out a little bit too early, but there was such a demand for working with drawings in this way that they brought it out early. And I can really proudly say that today is 2021 is a very clever, fully functional detailing mode for working with really large drawings. So have a look at how we do this. So I'm going to go and look at detailing mode and look at this assembly. Now, look at this environment at the bottom of here. I got the normal quick view, lightweight, resolved. Detailing mode opens up only a graphic, or not a graphic. The quick view is a graphic. Detailing mode is just the drawing without loading the models, but it will still connect to your model, but it doesn't load your model. So let me look at this. The same multi-thousand component assembly, nothing's in my RAM, everything's closed down, everything's off, it's not loading anything. If I say open, it takes, I don't know, 5 or 6 seconds to open up this 2,500 component drawing with multiple sheets. Now, again, I'm on 4 seconds, 5 seconds, that thing's opened. Now, what you will notice as well with the performance pipeline, or this performance booster in SOLIDWORKS with the GPUs I told you about, in 2021 SOLIDWORKS, all of that performance from the assemblies come to your drawings as well. So check this out. When you are working in drawings in SOLIDWORKS now, you will notice that the speed of panning, zooming, rotating, working has also all been shifted over to the GPU. So your supported graphics cards are going to crunch away these drawings at a crazy speed. Performance, improving performance on opening drawings, detailing view, creating sections, all of those things is that we do often are again enhanced with speed. But have a look at this top. This top part of the screen over here, where I've got all of my tools. Look at how much is available now in detailing mode. And again, this is a 2,000 component drawing. I opened up in 5 seconds. Look how fast I'm able to switch between the different the tabs of the drawings. It's crazy fast. And then I've got the functionality that, it's not just a view. I can actually work in this thing. I can detail. That's why it's detailing mode. It's a clever name. I can go in and delete the stuff. Work like I normally would. Add dimensions, add tolerances. Let's look at this bottom corner here. You can see this dimension is maybe not complete. This guy needs to move over a little bit. The leader is not complete. So we've got all of this functionality that we do in normal SOLIDWORKS detailing mode, and you can see I can just change the dimension that's already created. I'm going to fix that. I've also got tools like with the pop-up. I can add tolerances as well. So maybe I'm going to add a symmetric tolerance to this thing. It's fully functional now. You can create as you want. So this is super, the ability to dimension and add and work as you need be. Also, I've got a balloon, and I'm gonna create. Let me just put my balloon there. I want to just make a note of this balloon. I'm not going to use it for anything specific. Just going to put some text in there. I'm just going to call that 344. That's fine. And all of my properties are available to use. And something small for those in the automotive industry, there's a VDA leader that's now available for those who do work in the automotive space. Which is something small that has been requested with us, and I just wanted to show you that. So the VDA balloons are now supported as well. But this bottom section's been detailed quite nicely, but the top part of the drawing hasn't been done. So if I look at the drawing environment over here, I can add things like detailed views, crop views, broken views. So let's break this top view here as well, because that's something that I want to just detail. So, again, the model's not loaded. I'm going to create this in my detailed view, my broken view, and I'm going to dimension this now. Okay, so again, this is the functionality that was lacking last year, and this functionality allows you to actually work in detail in an environment that's going to be conducive to not needing the model to be loaded. I just need to add ordinate dimensions, for example. So I can add to the ordinate and just continue dimensioning as I need be to maybe the center line there, this end part. So SOLIDWORKS automatically adjusts that for me. And what about some detailing mode? I want to maybe detail this foot at the bottom over here. So again, detailing mode allows me to do a detailed view. So I'm going to do a detailed view of that foot at the bottom over there. And there it is. And maybe I want to add a dimension to that. Now I've even got these foreshortened dimensions that are there, which is really nice as well. And last but not least with this, I've actually got hole callouts. And you've got these context toolbars that are available. So if you just click in a view, you've got these context toolbars that you can customize yourself, or you can push the S key. You can customize that here too. And I'm going to do a hole callout. So even hole callouts are supported in this detail environment. Really, really nice tool. And what's great about this is I can save this. I can even go and save as. I can save this as a PDF. I can save this as a DWG or DXF. It's possible to do that as well. Again, it doesn't need the model loaded, and it does warn me if the model changes, which is you're saying, oh, but what happens if someone changes the model? Well, SOLIDWORKS is in the back end keeping those links, those references are there. If I save this and close it and work with it, and the model updates, it's going to warn me. It's going to block out the views and say, hey, you need to reload the model. It's changed. And SOLIDWORKS will allow you to load the model in. Now, something that's always been a bit of a frustration for me is when you're working inside of the drawing environment and you got sketches, but sketches were always done in drawings for some reason. They never had the same kind of intelligence that normal SOLIDWORKS had, and it was always strange to me. And now in SOLIDWORKS 2021, your sketches or your blocks have the same pop-up and same functionality that you would have while working in SOLIDWORKS sketching. So if I just select that midpoint there and that endpoint there, I've got the pop-up to make it coincident. And that's just so much easier when working inside of the drawing environment. So that's something small but handy. And I think I've covered everything. I think this detailing mode is amazing. I think this is going to be well used, and it's something that is one of my favorite enhancements in SOLIDWORKS in 2021. And I think I've covered everything for today. We've got some time. Please hang around. I'm going to just stop sharing my screen for a second.